Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is word search, and it's a medium level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. We are given with an m cross n grid of characters board and a string word. We have to return true if the word exists in the grid. The word can be constructed from the letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same cell may not be used more than once. So let's see an example. So we are given with an board, right, with the letters in each cell, and we have to construct a word that is ABCCED. Right, the word can be constructed from the letters in the cell sequentially adjacent. Means if the first letter of the word is A, then the B has to be adjacent of A, either in the same row or in the same column, right, either horizontally or vertically, right. So similarly, the letter C should be adjacent to B. It should be sequentially adjacent. So in this example, ABCCED is highlighted in the yellow color. So we'll return true. So let's see the idea or the intuition behind solving this problem. So we will be using backtracking to solve this problem. So we will use backtracking. So I've taken an example with a 3x4 board, and we have to search a word C. Now we start with the first cell of the board that contains the letter A, as A does not match with the S, right, the first character of the word C. So we'll move to the next cell. So B does not match with S, so move to the next cell. C also does not match with S. E does not match with S. Now S matches with the S. So as soon as we find the first character S matches with the S, so we'll mark it as visited. And from S we'll go up, right, down and left in the 4 directions. Sequentially find the other 2 letters of the word. So now we'll check the second letter, that is E. So from S, if we go up, the letter is A, so we cannot, that doesn't match with the second letter of the word C, so we will return. On the left side, as the board is finished, so we'll return. On the right side, the letter is F, so we'll return. On the down, the letter is A, so we'll return, as it does not match with the second letter E. So as from all the 4 directions, horizontally and vertically, the second letter does not match with E, so we will backtrack. So we have to backtrack. So when we backtrack, we have to mark this cell again as a letter S from the letter 0, right. We'll undo the change, right, to explore the other possible solutions or to move to the next cell. So if now we will move to the cell F. So F does not match with the first character of the word S, so we'll move to the next cell, that is C. C does not match with S, so we'll move to the next cell, that is S. S matches with S, right. So we'll mark it as visited. We'll go up, right, left and down. So as we go up, we see that the letter E in this cell matches with the second letter of the word C, right. So we'll mark it as visited. And from this cell we also go up, down and left. So as up and right, we are out of the grid or the board, so we'll return, right. And from the left, as the third letter E does not match with the letter C, so we'll return, right. And in the down, the cell is already visited, it's already marked 0, so we'll return. So as from the all the four directions we are returning false, right? All the returning false. So we have to backtrack, right? We have to backtrack. So now when we backtrack, we will mark again this cell from 0 to E, right? From 0 to E. So we cannot take this E, as if we take this E, then the third character E will not be present sequentially after this E. So we'll return false from here. Now if you see on the left side of S, we have C that does not match with the second character of word C, so we'll return false. On the right side we are out of the grid, so we'll return false. On the down we have the second character E that matches the second character of the word E, so we'll mark it as visited. From E we will go again up, right, left, so down and left. So up, the cell is already visited, so we'll return and we'll mark it as false. On the right we are out of grid, so we'll return false. On the down we are again out, out of the board, so we'll return false. On the left we have again letter E that matches the last character of the word C, so we'll as this is the our last character of the word, so we'll return true, right? So any of the four, from any of the four direction, if there is any true, so we'll return true, right? So we'll return true. So as we are getting true from true from here, so we'll return true, and from this cell we'll return true, right? So we have finally found our letter C in this board. So let's see the code part for it. I have written the solution in the Java language. So we are given with the exist method that returns the boolean. So the input parameter is board, that is a 2D char array, and the word that is of string type. So as we have to iterate over each cell of the board, so we need two for loops, one for the row and one for the column. Now we'll perform the DFS starting with each cell. In the DFS we are taking the input parameter as I, J, K, word and board, where IJ represents the cell on which we have to start the DFS, and K represents the character with which we have to match the letter present in the cell IJ, right? So we have our base conditions. So base condition is if we get out of the board, right, or from the left or the up or right or down, right, so we'll return false. Or if starting from a index, exploring the left, right, up, down, if we meet a cell which is already visited, so we'll return false. And if the letter present in the cell does not match with the letter, with the character of the word, then we'll return false. As you can see, the A was not matching with the first character of the letter of the word C, then we return false. So this is our first base conditions. Now if K is equal to word dot length minus 1, it means that we have successfully found the word. It means that the K becomes equal to the length of the word, then we'll return true. Now we'll take the letter in the cell IJ into the characters in the temporary variable ch, and we'll mark that cell as visited, and we'll perform DFS on the other directions. So suppose we are at S. So now the first character of the word matches with the letter present in this cell. Now we perform, right? Now we perform the DFS in all the other four directions. Now when we perform the DFS in the other directions, then for the character present in the next cell in any of the four directions, we have to match these characters or these letters in these cells with the next second character of the word C. So that is why we are passing k plus 1 to denote the next character of the word. And if from any of the 4 directions there is a match with the letter present in that cell and the next character of the word, then we'll return true. Otherwise we'll backtrack. So as we know, whenever we are at any cell, right, and when the character matches, so suppose if S matched with the first character of the letter of the word S, then we marked it as 0. We change the character from S to 0. Now at the time of backtrack, we again convert this cell, right? Whenever we backtrack from this cell, we change from 0 to S. So again this 0 will be converted to S and will return false. So once the DFS is done for all the cells, if the word is found for any DFS over ij, then we'll return true. Otherwise it will return false once we are done with the DFS over each cell. So let's run this program. So yes, the test cases are accepted, so it means solution is working fine. So let's see the time complexity of it. So as we are running 2 for loops here, right, and for each and 2 for loops, and we are performing DFS in 4 directions, right? So the total time complexity will be big O of m cross n cross 4l, right? So as we are performing the DFS, right, so we are performing 2 for loops, right, and we are performing DFS over each cell in 4 directions. So in any 4 direction I can go maximum up to the length of the word. So that will be L. The L denotes the length of the word. Length of the word. And M denotes the row and N denotes the column. For the space complexity, so as we are performing the DFS, we are going in 4 directions: up, down, left, right. So in any direction, the implemented stack can hold elements which will be the length of the word, right? So maximum size of the stack will be the length of the word. So the worst case complexity will be the order of L, where L is the length of word. I hope you enjoyed watching this video. If you like this video, please share and subscribe. Thanks for watching.